Welcome to Statics Lectures by Civil Thinking, and today we are going to solve a problem on movement due to forces and couples. Now, this is another lecture on force systems in statics. Now, before I move on, I request you to please watch my video lectures in sequence as in the playlist. I will provide the link in the description, and also the playlist link is here. Now, coming to the question, determine the moment about point B in the figure PA1. Now, we have to choose one option. Which one is correct? Okay. Now, let us begin finding moment at B. Moment at B is due to the forces at A, D, and C. Okay. Moment at B is not due to the force at B, that is 15 kilonewton. Why? Because it is passing through the point B, so the moment due to this one is 0. So we are only left with point A, D, and C. Now moment at B will be due to moment force 10 kilonewton at A, due to 20 kilonewton at D, due to 30 kilonewton at D, and due to 30 kilonewton at C. So summation of all the moments due to all the forces at A, D, and C, the summation of all the moments will be the net moment at B, and that will be the correct option. Now before solving, we have to make an assumption. Let's assume the clockwise moments to be positive, okay, and the anti-clockwise movements to be negative. This is my assumption, right? Now let's find. Now movement at B is due to the 10 kilonewton at A. It is going to be clockwise movement, right? Impose a clockwise movement at B, right? So it is going to be positive. So it is 10 multiplied by, what is the perpendicular or normal distance between the 10 kilonewton and the point B? It is 3 meters. So it is 10 kilonewton multiplied by 3 meters, right? Now at D there are two forces. Now let's first find due to 20. Okay, now 20, it is going to impose an anti-clockwise movement like this, so it is going to be negative. So I will write minus 20 multiplied by, what is the normal distance between point B and this 20 kilonewton. Now the line of action of this 20 kilonewton force is this CD. CD is the line of action of this 20 kilonewton, and the perpendicular distance or the normal distance between line of action of 20 kilonewton and the point B, it is from here C to B, right, or D to A, which is 2 meters, right? Now let's find 30 kilonewton. Now 30 is going to impose an again anti-clockwise moment, so it is minus 30 kilonewton multiplied by, what is the normal distance between the line of action of 30 kilonewton and the point B? It is 3 meters, right? Now if you don't know about line of action, I want to tell you line of action is a line around about which the along which the force is acting. Okay, so the line of action of 30 kilonewton is like this, right? So the distance between the line of action of 30 kilonewton and the point B, but the normal distance, right? We consider the normal distance. Okay, if you don't know about moment, please watch my video lecture on how to find the bending moment or the moment due to forces. So the distance here is 3 meter multiplied by 3. Okay, we have also found moment due to this. Now let's find moment due to 30. Now 30 is going to impose moment like this, right, which is clockwise. So it is plus 30 multiplied by, now it is CB far, right, so which is 2 meters. Okay, now when you solve this using the calculator, you will get, let me use the calculator, I get minus 40. Now this was, the forces were in kilonewton, right, and the distance were in meter, so it is kilonewton meter, right? So minus 40 kilonewton meter, so the correct option is B, right? I hope you understand this problem. Now we are going to solve more problems on moment due to forces and couples. Thank you for watching this video lecture. If you have any doubts, please comment. I will definitely help you. So see you in the next class. Thank you.